Hello, good evening, everyone.
Good evening, ma'am.
Good evening, ma'am.
Good evening, ma'am.
Yeah, this is your week 8 solve with us session. So, have you seen the content?
Yes, ma'am.
Okay, so what topics you have studied?
CLT and capital CLT, but the distribution part was a little bit confusing. The beta, gamma, and Chauvet distribution. That's the part I can't able to understand.
Yeah, those distribution in the last are like for introduction part only is there. We don't use those things as much. The gamma distribution, Cauchy distribution, yeah, but we'll see. 1 minute.
Ma'am, there is some background noise going on from your side, I guess. Could you? It's a bit disturbing.
Still it is coming?
Yes, ma'am. Some fans sort of sound. I guess it is.
Okay, is it fine now?
Yes, ma'am. It's perfect.
Okay. Okay, so we can start with the topics. So the first we have seen in this week is moment generating function. So what do you mean by it? In short, we call it as MGF. What is the formula for it?
E to the power E of
Expectation of.
equation of e to the lambda x.
Yes, so suppose we have a random variable x, okay? So x is a random variable, okay? Then the MGF of x, okay, it is denoted and given as so we represent it as m, x, and lambda, okay? And the formula for it is the expectation of e to the power lambda x. Okay, and this mx lambda, it is a function from real to real. Okay, so this is the formula for MGF. Now you can see that it is the expectation of some function of random variable x, right? This e to the power lambda x, it is actually a function of x, if you see it carefully, right? Now, if I have expectation of gx, suppose, so gx is some function of x. So how will you calculate this thing?
So integral of, if it's a continuous variable, then we'll do gx times the distribution that x follows dx
Yeah.
from minus infinity
So
to infinity.
suppose if x is a discrete, first of all. Okay. So if x is a discrete and you have to find the expectation of this function gx, then the formula will be summation of gx into the corresponding probability. Right? This is the formula. Now similarly, if you see that, again if I write that x is a discrete random variable, okay, with PMF, okay, we have discrete random variables, so we will have PMF, okay. So suppose the PMF is fx. Now if you have to write mx lambda, which is the MGF of x, so according to the formula, it is e to the power expectation of e to the power lambda x, okay. Now in this case we can assume that x takes values, okay, it is taking values like x1, x2 up to xn, okay. So if I use this formula, what can I write? So we have to write this function at different values of x, and we have to multiply it with the corresponding probabilities, right? So we can write that it is e to the power lambda x1, okay, and we have to multiply with the corresponding probability, okay. So the PMF, we are representing it with fx. So for all the values that x is taking, we have to write, we have to add it, right? So we can write this thing. Is it correct or not?
Yes, ma'am.
Okay, so we can write like this. Okay, and it will go up to nth term, okay, because here x is taking values up to n. So the last term will be fx, okay, this probability at point xn and e to the power lambda xn, okay. So this is when x is a discrete random variable. So this is how we can write the separate terms, okay, all the terms we can write like this. Now if x is a continuous random variable, okay, okay, with PDF fx, okay. So now this will simply be the integration of that function, right? Integration of e to the power lambda x into fx, which is a PDF here, over the range of x, right? So this is the general formula for finding the MGF. Now, why this is called moment generating function, this function? So we can see with the formula itself. So why is it called moment generating function? So if you look at the formula, it is mx lambda equals to expectation of e to the power lambda x, okay. Now if you remember this expansion, e to the power x, what is the expansion of this?
1 plus x plus x square by 2 factorial
2 factorial.
Factorial.
Yeah.
So 1 to x power n by n factor.
Yeah, so it goes like this. So we can apply this formula here also. We have to use this expansion here. So here we have e to the power lambda x. So it will be 1 plus lambda x plus lambda x whole square divided by 2 factorial plus lambda x whole cube divided by 3 factorial and so on. Okay. Now if we take the expectation inside this bracket, so expectation of 1 will be what?
1.
1 because it is a constant, okay, and expectation of a constant value is that constant value only. Now here we have lambda x, so it will become lambda times expectation of x, right?
Yes, ma'am.
Then it will become lambda square divided by 2 factorial into expectation of x square, right? And similarly it will go for the other terms as well. So this will be lambda cube divided by 3 factorial into expectation of x cube. Now you can see in this way we are getting expectation of x, this expectation of x, then expectation of x square, this expectation of x cube. So these terms are nothing but the moments. Okay, so this is expectation of x only. So this is called our first moment. Okay, this function is the first moment. Then expectation of x is square when we have power 2. This is our second moment. And similarly, this will be our third moment. So now you can see that by this formula, by this function, we are getting the moments of the random variable x. So it is generating the moments through this formula. That's why this function is called as the moment generating function. Okay. So moments are not in your syllabus, but I'll give you a brief description about it. So moments, basically we have two types of moments in statistics. Okay, so first we have raw moments. And second we have central moments. Okay, so raw moments are like the formula for raw moments. So the nth raw moment, it is denoted like this, and the formula is expectation of x to the power n. Okay, so if you want the first raw moment, so mu1 dash will be expectation of x to the power 1, which will be expectation of x only. Okay, which is our mean also, right? Then similarly you can find for the n is equal to 2, so it will be mu2 dash, so it will become expectation of x square. Okay, so this is how you can see that it is like it is giving you the moments. So this is the general formula. So depending on the value of n, it depends like it is your first moment or second moment. Okay,
Yes, ma'am.
and the central moment, so you can see central moment are like the nth central moment. So what we do is we subtract by the mean. So this is expectation of x minus x bar, and then we have to take power n. Okay, so now if you look at it carefully, if you put n equals to 2, so this will become expectation of x minus x bar whole square. This x bar, I can write it as expectation of x also, right? These two are same thing. Now what
Yes,
is
ma'am.
this formula? This, is it known to you or not? What is this?
The variance.
Not variance. Making the mean zero, ma'am. Like the random variable to zero mean.
This is the formula for variance actually. Okay. You look at the formula carefully, it is a variance of x. So we can see that the second central moment is variance and the first raw moment is mean. Okay. You don't need to go very deep about these topics, but this is how we get the moments of that random variable x.
Ma'am,
Yes.
I have one question. First central moment is mean deviation.
Yes, so it will be so expectation of x minus x bar.
Yes, that is mean deviation, right?
Yes.
Okay. Thank you.
Okay. So when you are taking these, like you are subtracting the mean, you will get the central moment. And similarly, you can see if you put 0, if you are taking 0 here, that's how it becomes the raw moment. So it is, you can write it like this, that x minus 0 whole power n, right? So in central moment, we have to subtract by mean. We have to subtract the mean value. Okay. Now, this formula, you can see that if you have a random variable, which is a discrete random variable, and you know the values taken by the random variable x, okay, you can write the MGF of that variable, right, by using this method, right? So we'll see the questions later. First, we will write all the concepts that we have, and then we'll solve the questions, okay? So we'll see how we can write the MGF if you are given the values of x and the corresponding probability. Okay. Up to this point, everything is clear to everyone?
Yes, ma'am.
Now there is a note point. If you have seen the lectures, you will notice it. So if you have a random variable x, which is following normal distribution, okay, with 0 comma sigma square. So what is the MGF of it?
C to the
e
lambda
to
square
the
sigma
power
square.
lambda square sigma square by 2.
Yeah, so it is e to the power lambda square sigma square by 2. So it's better if you remember this result. It will be helpful in solving the questions. So if there is like mean is 0, then this is the formula. And if x is following normal with mean mu comma sigma square variance, so then MGF is e to the power mu lambda plus half sigma square lambda square. Okay. So when you put mu equals to 0, you will get this formula. Okay. These both are same. You put mu equals to 0 and you will get this one. Now if you have IID random variables, then how will you find the MGF? So MGF of sum of, suppose we have two independent random variable. Okay, so suppose we have x1 and x2, okay, which are IID with some distribution x. And now we are defining another variable y, which is the sum of these two variables, x1 and x2, okay? Now you are required to find the MGF of y. So how can we find it? So we should we have to use that simple formula only, expectation of e to the power lambda x. Here we have y. Okay, then what we will do? So first step should be writing the formula that we have studied. So it will be expectation of e to the power lambda, and here we have y. So we will write y here. Okay. Now next, we can put the value of y, right? So we have expectation of e to the power lambda, and y is equal to what? X1 plus x2. We will do those things we know. Okay, simply. Then we can write e to the power lambda x1 plus lambda x2. Now this can be written as, okay, this is just simple mathematics I'm doing. Okay, is this clear to this up to this point?
Yes,
Yes,
ma'am.
ma'am.
Yes,
Okay.
ma'am.
Okay, now we know that these random variables are independent of each other. Okay, since they are independent, we can write it like this.
Yeah, multiplication of
Yes,
individual.
multiplication of both. Okay,
Yeah.
because they are independent, so we can write like this. Now, if you look at this thing only, what it is?
Yeah, my lambda.
Yeah, it is the MGF of x1.
MG of x1.
Okay,
X2.
and this is the MGF of x2.
X2.
Okay,
Yeah.
so now this is one of the results. So if you have independent and identically distributed random variable, IID random variables, then the sum, if you are finding the MGF of sum of those IID random variables, so it is the product of their individual MGFs. Okay, so I can write and this result is true for like multiple random variables also. Here we have seen for two variables. If you have m variables, then also you can use this result. So I can write that the MGF of sum of IID random variables, okay, so is product of product of their individual MGS. Okay, is it clear to everyone?
Yes, ma'am.
Okay, next we have seen the concept of centralized random variable. Okay, so what is centralized random variable is, what we do is we subtract the mean of the random variables from each x1, x2 up to xn. Okay, so we are just centralizing our data set. So what we have to do, we just subtract the mean. So centralized random variable, suppose you have x, okay, which is taking values x1, x2 up to xn, suppose. Okay, and the mean of this data set is suppose mu. Okay, mean is equals to mu. Now how can I find the centralized data set? So centralized x, so this will take values x1 minus mu, then x2 minus mu, and similarly you have to subtract the mean from all the data points. Okay, so this actually helps to understand the data set better because you are centralizing it. Now if you see the mean of this data set, okay, this will become 0. Okay, so this actually helps to simpler the calculation and interpret the graph easily. Okay, that's why we can do these things in our data set if required. So we can write that the mean of centralized x, one minute. Yeah, so mean of centralized x will become 0. Okay. Now the next topic is central limit theorem. So what is central limit theorem? Anyone?
It is used to find the average of multiple sample cases
Normal zero.
or distribution normally. Yeah, we converted distribution to normal distribution, and then we kind of find like the sample mean or something.
Yeah, so the idea behind central limit theorem is, suppose you have a large population and it is following some distribution. It can be known to us or it can be unknown to us. Okay, so what happens is, if you are taking a large sample, then the distribution of the sample mean tends to follow normal distribution, standard normal distribution. Okay, so if you see in real life, we can have some data set where we don't know the actual population, like we don't know the actual distribution. Okay, what distribution that population is following. So we can use the central limit theorem in that case and we can find the probabilities. Okay, so this is the basic idea behind central limit theorem. So we can write that if you have x1, x2 up to xn, some random variables, okay, and these should be IID. So suppose if the expectation is 0 for this data set, okay, and the variance suppose is sigma square. And then if you have a random variable y, okay, which is x1 plus x2 up to xn by root n. And if you see, if you calculate the MGF of this y, okay, then it tends to be e to the power lambda square sigma square by 2. Okay, these are some results that I am writing here. So if we calculate the MGF of this y here, you will see it tends to be this function. Now, if you see this function carefully, what it is actually?
Normal distribution.
MGF of normal
MGF of
Yeah.
distribution.
MGF of normal distribution.
Yeah, so it is the MGF of normal distribution. Okay, so we know that MGF of normal 0 comma sigma square. Okay, it is nothing but e to the power lambda square sigma square by 2, right?
Yes,
Yes,
ma'am.
ma'am.
Okay, so now we can say that y is set to converge in distribution, okay, to normal 0 comma sigma square. Now the main thing is which we have to see is how we can use this CLT in real life. How we can like what is the main application part of the central limit theorem. So in real life, we don't know the actual distribution of the population, but if we make it into a normal distribution, so we know that we have a standard normal table and the normal table where we can find the probabilities for all the values, right? We have normal, if you have seen the tables, we are given some values here and some probabilities values are given, right? By using that, we can find the probabilities, because for normal distribution we know everything. So that's the same thing we have to do here. So using CLT to approximate the probabilities. Okay, so how can we do it? Now suppose you have x1, x2 up to xn. This is some variable, okay, which are IID. Okay, now suppose the mean for those variable is mu. Okay, they will have some mean, okay, which is represented by mu. And then they have variance sigma square. Okay. Now the summation of these random variable x1 plus x2 plus xn, okay, which is represented by y here. Now this summation, and when you subtract the mean, so what will be the mean of y here? So you
Could you
can,
repeat your question?
yeah, so I am saying what will be the mean of this y?
X1 plus X2 up to Xn upon N.
So basically we have to add the mean of these random variables, right?
Yes, I mean
Yeah.
N times
Mu.
Xi.
So it will be n mu, okay?
Yes.
Because these random variables have mean mu and they have n in numbers. They are n in numbers, so it will be n mu simply.
Yes.
So what we can do is we subtract the mean, okay, and divide by the standard deviation. So similarly, you can find the variance of y. So it will be the variance of x1, x2 up to xn, okay? So this will be n sigma square, right? You just have to add them.
Root n sigma square, I guess.
No, it will be n sigma square.
Okay,
So this
okay.
is the variance. And when you take standard deviation, then it will be
N
sigma,
sigma.
Okay, got it.
yeah, sigma root n. Okay. Now
Yes.
this value, this quantity, okay, this is approximately normal. Okay, normal 0 comma 1. So this result we have to use in our questions. Okay, is this clear to everyone? Yes, no?
Yes, ma'am.
Okay, so these are this is the overview for the topics of week 8. Now we'll see the questions. Okay, there's an MGF and there's CLT. Okay, so this is your first question. So here we have x, which is following uniform. Okay, 1, 2, 3. Now we have to find the MGF of centralized x. So first of all, we need the centralized x, right? And we are given the simple x. So what should be the first step?
Finding
Finding the mean,
Finding
and
mean.
subtracting.
We will find mean and subtract from every single random variable.
Yes. So here we have uniform, discrete uniform, which is taking three values, 1, 2, and 3. So what will be the mean of this x here?
2.
So mean of x will simply be 3 plus 1 divided by 2, which is 2. Okay. So mean is 2. Now the value of centralized x,
-1, 0, and 1.
yeah, so it is 1 minus 2, then 2 minus 2, and 3 minus 2. So this will become -1, 0, and 1, right?
Yes, ma'am.
So now our centralized x random variable is taking these values. Okay. And we
Ma'am,
know that,
can we say this range? New range.
yeah, this is the like values taken by centralized variable x. Okay.
Yes.
Now it is a uniform distribution taking three values. So what will be the probability corresponding to each value here?
1 by 3.
So it will be 1 by 3. Okay. Probability will still be same here also. We just have centralized our data set. Probability will still be the same. Now we have to write the MGF of the centralized variable x. So what should I write here now?
It's 1/3 of e to the minus lambda plus 1/3 of e to the power 0 plus 1/3 of e to the lambda.
Yes. So again, we'll go back to that formula.
Expectation of e to the power lambda x.
Yeah, this one. Okay. So we can see that we have to write e to the power lambda into the value taken by x. Okay. And we have to multiply with the corresponding probability. And we have to do it for all the values. Okay. So we have to add them. So this formula we can apply and we will find the MGF of x here. Okay, so here we can see it is taking value -1 with probability 1 by 3, then 0 with 1 by 3, and 1 with 1 by 3. So e to the power minus lambda, right? Lambda into -1 into 1 by 3, then 1 by 3 e to the power 0 into lambda, right?
Yes.
Then 1 by 3 e to the power
Lambda.
lambda into 1, which is lambda. Okay. So simply we can write it is e to the power minus lambda plus e to the power plus lambda plus 1 divided by 3.
3.
Okay, is it clear to everyone?
Yes, ma'am.
Okay,
Yes,
this is the
ma'am.
MGF of centralized x. Okay, then solve this question. So here x is following Bernoulli 0.3. And we have to find the MGF of centralized version of x again.
Can you show the formula, ma'am?
You don't need to remember, like, don't need to mug up this formula like this. You just understand what we are doing.
Can you show the question?
Ma'am, I think it should be 0.3 e to the power lambda plus 0.7.
Okay, so first of all, we should know the values taken by x. And
Ma'am,
then we
option D.
0 and 1.
yeah, and then we will centralize. So x here belongs in 0, 1, right? It is a Bernoulli random variable, so it will be taking two values, 0 and 1.
Yes.
Okay. Now we have to see what is the mean. Okay. So what will be the mean here?
Oh, centralized.
1.
Half.
0.3 times 1. So that's 0.3.
So you can see x is following Bernoulli 0.3. Okay. So this is nothing but the value of p. Okay. And if it is following Bernoulli p, the mean is that p only. So the mean of x will be 0.3. Okay, now we have to make it centralized. So centralized x, which means we have to subtract the mean. So 0 minus 0.3 and 1 minus 0.3. Okay, so this will become minus 0.3 and 0.7. Okay, now what will be the probabilities for these values?
0.3 and
0.3 and
0.7.
0.7.
0.3 for what? 0.3 for 0.3 minus for 0.7.
0.7.
Yeah, so you can see that again. First look at the original x and then go to the centralized x. Okay. So you can see for when x is taking value 1, the probability will be 0.3. Okay, this value. And when it is taking value 0, it will be 1 minus 0.3, which is 0.7.
0.7.
Okay. So for minus 0.3, probability will be 0.7. Okay. And for 0.7, probability will be 0.3.
0.3.
Now we can write the MGF of centralized x. Okay. So e to the power lambda into x1. So minus 0.3 lambda, and the probability is 0.7, plus e to the power 0.7 lambda, and probability is 0.3.
0.3.
Now we can see which option is matching with this one. So which one will be the correct option?
D.
D. Right? Is this clear to everyone?
Yes,
Yes,
ma'am.
ma'am.
Okay. Yeah, solve this question. So here, let x1, x2 up to x10 be IID random variables with common moment generating function mx lambda. Then find the MGF of x bar. Okay, where x bar is what? It is a mean of these x1 up to x10. Okay. So what is the moment generating function of z in terms of mx? This z is actually x bar. Okay, in terms of mxt. So we have to find the moment generating function of x bar. Okay, this is missing in the question. So I'm writing it here. Solve it.
Ma'am, is it option D?
Yeah, okay. How we will solve it?
Uh, the expansion, ma'am, like there are multiple random variables, so some of them would be e to the power x1 plus x2 plus x3. We can using exponential formula we can just do the multiplication, and since they are IID, so everyone would be same.
Yeah, so here we can use the property also that sum of independent random variable. Okay, like if you have to find the MJF of some of IID random variables, so that will be the product of their individual MJFs. Okay, or if you don't remember, we can just use the formula of MJF and we can simply find it out. So we have to find, first of all, x bar is given as 1 by 10 x1 plus x2 up to x10. Okay, this is the function we are given and we have to find the MJF of this function. So we have to find mx bar lambda. So it would simply be expectation of e to the power lambda x bar, right? Now I can put the value of this x bar here. So this is 1 by 10 So I can write 1 by 10 x1 plus x2 up to x10. Okay. Then I can simply write expectation of, so we can write lambda by 10 x1, okay, into lambda by 10 x2, and this will go up to lambda by 10 x10. Right? Is this clear to everyone? This step? Anyone has any confusion in this step?
No, ma'am.
Okay, just simply if you open the bracket and it is in like summation, so we can write it in the multiplication. Okay, now they are IID, we know. Okay, it is given in the question. These variables are IID. So again, we can write it like this: expectation of e to the power lambda by 10 x1, expectation of e to the power lambda by 10 x2, and then expectation of e to the power lambda by 10 x10, like this. Okay. Now, if you look at these terms carefully, that so in the question it is given that these random variables have a common MJF mx lambda. Okay. So what should be this term?
mx lambda.
So here we have 1 by 10 also. Okay. So it is not directly mx lambda.
mx by 10 lambda.
So we write it like this, that mx lambda by 10.
Yes.
Okay.
Okay.
So there is one result. I'm writing it here. So if first of all we have mxt, okay. So this is we know the formula. This is like simple, okay. So if you are given mxct, so which what you are doing, you are multiplying some constant here, okay. So what it will be? So it is nothing but mxct.
CT. Okay.
Okay, these two things are same. So we are using this thing here, okay.
Yes, ma'am.
So we can write it like mx lambda by 10. Okay, and similarly these terms. So mx, this will also be lambda by 10. Why am I writing it x only, not x and x2? Because it is given that they have common MJF mx lambda. Okay, so we can simply write x for all the terms. So mx lambda by 10. So in total, how many terms we have?
10.
10. Okay, because we have x1, x2 up to x10. So it will have power 10, mx lambda by 10, this term, and then whole power 10. Right?
Yes, ma'am.
Okay. Now you can see which option is correct.
Option D.
Option D. Is this question clear to everyone? If any doubt,
Yes,
you can
sir.
ask now. Okay. Okay, so simply just remember this result and you can use it. Okay, so this one. So here x1, x2, x3 are IIDX and x is following uniform with values -1, 1. Now we are given y, which is x1 plus x2 plus x3. Then we have to find the distribution of y. So how you will approach this question?
Ma'am, we'll find the MGF. From there, we can go to the distribution, to the PMF.
Yes,
Which,
yes. Yeah.
yes.
So we will find the MGF of y first. Okay. And from that MGF, we can write the PMF of y,
Distribution.
distribution of y.
Yes, ma'am.
Okay. So how you will see it, let me explain it again. Again, the same formula that we have seen at first. So here you can see. So you will find the MGF in this way, in this like this. You will get some terms like this when you find the MGF of y. Then what you have to do, you have to see the coefficient of lambda here. Okay, e to the power lambda, and you will have something in multiplication with lambda. So that is the value taken by x, and whatever is in the multiplication with this term, basically this fx. Okay, so this will be the corresponding probability. So that's how you can determine the values taken by y and the probabilities corresponding to those values. So first we will find the MGF. So calculate the MGF first here.
For x, MGF is 1 by 2 times e power -1 plus e power 1. And whole cube of that will give MGF of y, ma'am.
Yeah, so first we will find the MGF of x. And then simply we have to use the property of MGF. Again, we have IID random variables and we are asked to find the MGF of some of those IID variables. Okay, which is equal to the product of their individual MGFs. So we can use the property and we can find the MGF of y. So my lambda, I'm writing all the steps here, so it will be e to the power lambda y. Okay, then again e to the power lambda x1 plus x2 plus x3. You can directly write that the product of mx1 lambda and mx2 lambda and mx3 lambda, but I'm solving it here. So it will become okay, then it will be, these are IID, so we can write them separately like this. Now these three are the MGFs of x1, x2 and x3. Okay, so mx1 lambda, mx2 lambda and mx3 lambda. And since all the three random variables are following the same distribution x, okay, which is uniform -1, 1. So what can I write here? So it will be, so these three values are actually same. So I can write this is mx lambda whole power 3. Right? Is it correct?
Yes, ma'am.
Okay. Now we need to find the value of this mx lambda. Right? So mx lambda. What is the value of this mx lambda?
e to the
One.
power minus lambda plus e to the power lambda upon 2.
Yeah. So e to the power minus lambda plus e to the power lambda divided by 2.
2.
Right? So this is the value of mx lambda. So which implies that the value of my lambda will become the cube of it. Okay. Now we need to open this cube, right? And then we will get all the different values, right? We will get all the terms, and then we can decide the values and the probabilities. We have to make it in that form that we have studied. Okay, here it is a different kind of thing. We are given in the cube form, so we have to open it. Okay, so this will become 1/8. Then we have e to the power minus lambda whole cube. So e to the power minus 3 lambda. Then it will be e to the power 3 lambda. Okay, so you simply have to use this formula, a plus b whole cube. Okay, then e to the power 3 times e to the power
Square
minus lambda.
minus 2 lambda. Yes.
Yeah, then 3 e to the power lambda. Okay, the formula is...
Ma'am, the last two steps, it's like 3a square b plus 3ab square, right? Could you just
Yes. Yes.
could you tell me how did you simplify that?
Okay, so you can see that this is 3, and then you have to take like square of one term and the other term, right? A square b and ab square. So if I consider this a and this as b, so this will be e to the power minus 2 lambda into e to the
We
power
cancel
lambda.
it. Yeah.
Okay,
we
then it
cancel
will become e to the power minus lambda.
Okay. Yes, ma'am, it's clear. Yeah, thank you.
Okay, is it clear to everyone up to this
Yes,
point?
ma'am.
Okay, now we have to see the coefficients of lambda here, and then the total like coefficient of e to the power lambda x. Okay. Okay, so what value is taken by y?
Minus
Uniform
3,
minus 3, minus 1,
minus
1,
1.
and 3.
Yeah. Yes, ma'am.
Yeah, so in the first term, you can see the coefficient of lambda is minus 3. Okay, so minus 3 is one of the values.
Minus
Then we have 3, minus 1, and 1, right?
Yes, ma'am.
Yeah, so we have minus 3,
Minus 1,
minus 1,
1,
and
3.
3. Okay, now what is the probabilities?
1/8
1 by
and 3/8, 3/8, 1/8.
Yeah, so don't get confused by this bracket. So this is 1/8 for all the terms. Okay, so for this term it will be 1/8. Then for 3, so the coefficient is 1/8. Then for minus 1, we have 3/8, right? And for 1 also, we have 3 into 1/8, so 3/8.
3 by 8.
Okay. Now this is our PMF or the distribution of y. Any doubt? Is it clear to everyone?
Yes, ma'am.
Okay. Okay, so these type of question you will see regarding MGF. Okay. Now next question is that let x1, x2 up to x100 be independent, identically distributed random variables, each with expected value mu. Expectation of xi will be it is 3, and variance sigma square is 9. Now you have to approximate probability of x1 plus x2 up to x100 is greater than 100. So this probability we have to approximate by using the central limit theorem. And here it is written that write your answer in terms of FZ, the CDF of standard normal. Okay, so how we will solve this question? Try it and then I will solve it. Is it done?
Ma'am, could you solve it? Like I'm having a problem subtracting mean and dividing by root n.
Okay. Okay, so first of all, we are given these random variables are IID, and the mean is 3 and the variance is 9. Okay, so so these variables are following some random variable x, suppose, and the expectation of xi, which is mu, it is 3, and the variance of xi, which is sigma square, this is 9. Now the thing we have to calculate is we have to approximate this probability, x1 plus x2 plus x100. This is greater than 100. This is something we have to find. Okay, now let's suppose, let this summation x1 x2 up to x100, if I write it as s, okay, which is representing the summation, so I'm writing it as s100. Now if I use the CLT, so using the CLT, what can I write here is, so this summation, right? So what is this summation? This is the summation of 100 IID random variables. Okay. Now if I subtract the mean of it, okay, the expectation of S100, okay, and divide by the standard deviation of this value, this quantity.
3.
So standard deviation of S 100. So this will follow, okay, normal 0, 1. So we have to do some manipulation here in this term. We will convert it like this, and then we can approximate this probability. Okay, so what we need to calculate here? We need to calculate these two values, expectation of S100 and the standard deviation of S100, right? So now first of all, we will find these values. So expectation of S100. So this is equal to expectation of X100 is the summation of these 100 random variables. Okay. So now you can see that we are given the expectation of Xi, which is 3. So this is 3, expectation of Xi is 3, and we have 100 IID random variables. So what will be the expectation of S100?
100 times 3.
Yeah, 100 into 3. So this will be 300. Similarly, we can find the variance of this variable S100. Okay. So this is same like that. So variance of X1 plus X2 up to X100. Again, it will be 100 times of sigma square. Okay. 100 times variance of this X1 or X2 or X3 or X100. So the variance of Xi is 9. So 100 into 9. Okay, is this clear to everyone?
Yes, ma'am.
Okay. Now we come back to the thing which we have to calculate, this line. Okay. So we have to calculate probability that x1 plus x2 plus x100, this is greater than 100. Okay, this is something we have to find. Now this x1 plus x2 plus x100, I have written it as S100, right? Just
Yes,
for
ma'am.
notation, I have written this thing, okay? So this is S100. You can represent it by any other variable also, it's your choice. Now what we have to do, if we subtract this mean and divide by the standard deviation, it will tend to follow normal 0, 1. So we have to do this manipulation here. So we can write that S100 minus, now we have calculated the expectation of S100. The value is 300.
Yes, ma'am.
Okay. And the variance is 900. So standard deviation of S100 will be square root of 900. Okay. So here it will be 300 divided by square root of 900. Okay. Same thing we have to do at right hand side also. So 100 minus 300 divided by square root of 900. Is it clear to everyone till this point?
Yes, ma'am.
Okay. Now we know that this is what this has become a standard normal variable, right? And generally the standard normal variable is represented by Z. So we can simply write it like this. Yes or no?
Yes, ma'am.
Okay. So this we can write as Z and calculate this value. So this will be minus 200 divided by 30, right? So this is probability
Yes, ma'am.
Z is greater than, this will be minus 20 by 3. Okay. Now I can write this term as 1 minus probability that Z is less than or equal to minus 20 by 3. Right?
Yes, ma'am.
Now what is this? What is this term?
FZ of 20
CDF.
minus 20 by 3.
Yeah, so this is the CDF of standard normal. So CDF, which we represented by capital F and Z, and the point is minus 20 by 3. So this is your answer. Now in the question, if you are given these value, you can put it here. Otherwise, in this question, it was given that you have to find the answer in terms of HZ. Okay, so this is your final answer.
Ma'am?
Yes.
Ma'am, you should like remove the minus sign from the inside, I guess,
No.
in the answer.
No. It is just like the complement of it. If you have probability A plus probability A complement, this is one. Okay, if you represent it on the real line, okay.
Okay, got it.
So this is greater than, which means this part. So how we are calculating it? The entire is 1. So from entire, we are subtracting this part, which is less than minus 20 by 3 only. Okay, then you will get this part, right?
Yes, ma'am.
This red part. Okay.
Ma'am, please explain first half part.
Ma'am, could you explain the whole question, like with step-wise what we have to do first, like?
Yes. Yeah. So read the question carefully. What we are given that we have 100 random variables which are IID, and their mean and variance are given to us. Okay. Now we have to find that probability x1, x2 up to x100, it is greater than 100. So we have to approximate this probability. Okay, this thing we have to find. So what we can do here, if you remember the CLT carefully, yeah, so we have to use this thing. Okay, so we are given some IID random variables, okay, which will be following some distribution. So their mean and variance is given to us. Okay, or sometimes it's not given, then we can calculate it. Okay, the information will be given to you. Now what we know that we have the sum of these random variables. Okay, now this y is representing the sum. What we have to do, we have to subtract the mean of this y and divide by the standard deviation. Then this variable becomes z, which is a standard normal variable. So we have to do the same manipulation in our question. And once we convert it into a standard normal variable, then we can simply use the CDF of standard normal and we can calculate the probabilities. So this is the rough idea of doing these questions. Okay, so 2 things you should know. You have to calculate the mean of this variable, and you should know the standard deviation of it. Okay.
Yes, ma'am.
Now go back to the question again.
Ma'am, the standard deviation of a mean is sigma by root over n, right? Like for a mean.
See, 2 things are there. If you are taking this y as the summation only, okay, so CLT you can apply on the summation of these random variables or the mean of these random variables. So here we have summation. Okay, so if you're taking the sum, then it will be n mu mean, and standard deviation will be sigma root n. If you're taking the mean, okay, then it will become sigma by root n. But here it is not mean, it is the sum only.
Or we should just simply convert it to the sum, right?
Yeah,
in the
simply,
inequality.
Yeah, so simply we were given the sum only. So we can use that only. Otherwise, if in the question it is talking about the mean, then you can use it for the mean. Okay, we have questions. You will see it there.
Ma'am, a small query. Over here, since you said for sum, we have to do it in this way. For mean, we have to take sigma by root over n, right?
Yeah.
Over there for mean, n mu is there for over here. For sample mean would be same, since we we need not multiply n for the mean, right? Am I right?
See, the thing is, it depends on the variable y. So the thing is, you have to subtract the mean of this variable. Whatever you are taking this, okay, depends on that. So here y is equal to x1 plus x2 up to xn. Okay, you have to find the expectation of y and the variance of y. Okay, don't mug up these things. You can just calculate it. Okay, so what will be the expectation of y? Expectation of these terms. Now it simply will be n times mu,
Yes, ma'am.
right? And if you calculate the variance, so it will be variance of x1, x2 up to xn. Okay, so this will become n sigma
N
square,
sigma square.
right? And we have to take the standard deviation, so this will become sigma root n.
So, ma'am, can we write this equation as y minus e of y divided by sd of y? That's what you
Yes,
mean,
yeah,
right?
yeah, that's
Yeah,
what I
okay.
mean. Yeah, it is nothing but the expectation of y divided by the standard deviation of y. Okay, so you can always calculate the expectation and standard deviation for this variable y. Okay, now sometimes this y can be the summation of the variables or it can be mean also. Okay, we have some other question, you will see it there. So if in the question it is talking about the mean, you can solve it for the mean. So here you can simply see that x1 up to x100 is given, right? And it is greater than 100. So what we can do, we have to subtract the mean of this variable and divide by the standard deviation. Already we are given the sum. So just calculate the mean of this x1, x2 up to x100. Okay, this summation and the standard deviation of it. Okay, that's what we have done here.
No, are we subtracting the mean from it also or not in this question?
Yes, we have done it.
Okay.
Okay, this is what? This is S100. Okay, this is just for notation. Okay, to make it simpler, you have to subtract the mean of this entire quantity. Okay, which we have calculated here. You can see.
Yes, ma'am.
Okay, which was 300 and variance was 900, so standard deviation will be square root of it simply. Okay, so subtract the mean, divide by standard deviation. Now it has become a standard normal variable, so now I can simply find the probabilities. Okay, do this thing on both the sides. Okay, we have to make it balanced mathematically, right? So whatever you are doing, you have to do on the both side. Then our equation will be balanced. And then you will get some quantity. And you have to use the properties of normal distribution and you can get the answer. Now is
Ma'am,
it clear?
ma'am, can I
Once
solve
more.
this with the given formula in the lecture?
Yeah, which formula?
1 minus CDF of delta mu under root n upon sigma. The formula was shown on the lecture.
Okay, so ultimately we are doing the same thing. Okay, it might be a different notation. So this is the thing that we have to do.
Here FZ is the like CDF, right?
Yeah, this is the CDF of standard normal.
Okay, I was getting confused with like the PMF. I thought it is
But
PM.
ma'am, using that formula, how to solve?
You have to use this method. This is the method which is described in the lectures also.
Ma'am, I have a question. So, in this case, it was actually S100. Suppose there is a different equation given, let's say like a product x1 into x2 into x3. Then, let's say y equal to x1 into x2 into x3. Then, will it be the same? Will it be the same equation? Like, for example, y minus e of y by standard deviation of y. can I use the same
No, so
formula
this
that you
CLT
used?
is for summation or for the mean only, not for the multiplication.
Okay,
Yes.
understood.
Okay, let's see the next question. Then I think it will be more clear. So the second question is, suppose speed of vehicle on a particular road are normally distributed with mean 25 mph and standard deviation 3 mph. So find the probability that the mean speed x bar of 30 randomly selected vehicles is between 24 and 27. So what we can do here, we can suppose that x is some random variable which is representing the speed of vehicles. Okay, so this is representing speed of vehicles. Now this speed of vehicles on a particular road are normally distributed with mean 25 and standard deviation 3. So we can write that x is following normal. Okay, mean 25, standard deviation is 3. Okay, is this clear? Simply whatever information is given, we just write it first. Now, what is asked? Find the probability that the mean speed x bar of 30 randomly selected vehicles. So 30 randomly selected vehicles, which means the sample size is given to us, which is 30. Right?
Yes, ma'am.
So simply the value of n is given to us. And then it is saying that this x bar is between 24 and 27. So what we have to find is probability that this x bar, okay,
is between 24 and 27.
yes. So this is something we have to calculate here. Okay. Now what we do here, again we can do the same thing, that if you subtract the mean and divide by the standard deviation, this will become into a, this will tend to follow, yeah, standard normal
Z.
distribution. Now we have to see, so we need to find the value of the mean of this x bar. Okay, and the standard deviation. So we can see that x bar is x1 plus x2 plus xn divided by n, right? This is the formula for x bar. Now, if you calculate the expectation of x bar, this will be 1 by n times expectation of x1 plus x2 up to xn, right? So now this will become 1 divided by n, and this quantity will become n times mu, right? So ultimately, the expectation of x bar will become mu, right?
Yes, ma'am.
Okay. Yes, ma'am. Now it's clear. Yes.
Okay. Now we have to find the variance. We have to find standard deviation, so we need to calculate variance of it. You have to find the variance of this equation, okay? So it will become 1 upon n square times variance of x1 plus x2 up to xn, right? So this is 1 by n square into this will be n sigma square, value of this term only. Is it clear?
Yes, ma'am.
Okay. Now if you solve, this will become sigma square by n. That's how it becomes sigma square by n. Okay. Now if you find the standard deviation of x bar, so this will become sigma divided by root n. Is it clear?
Yes, ma'am.
Okay. Now, okay, we don't have enough space here. So this is standard deviation of x bar is sigma square by, sigma by n, root n. So we have to find probability that X bar is lying between 24 and 27. Okay. Now what is this equation? So we have to subtract the mean. So this is X bar minus mu divided by sigma by root n. Okay, now this step is clear. We have to subtract the mean of this quantity and divide by the standard deviation of it. That we have calculated here. This is the mean, which is mu, and the standard deviation is sigma by root n.
Ma'am, after calculation, it will be Z.
Yeah, after doing this manipulation, this variable will become Z. Okay. Is this part clear to everyone? What we are doing here? This mu and sigma by root n.
Yes.
Okay, we have to do it on all the sides. So this will be 24 minus. Now we need to find the value of this mu. So you can see here that mu. So mu is what? Mu is the expectation of this x1, x2, and xi.
It's
25.
25.
So this is 25. Okay. And the sigma square. So sigma is given as 3. Standard deviation is 3, right? This is our mu comma sigma square. Okay. So mu is 25 and sigma square is 3 square. Sigma is 3. Okay. So minus 25 divided by sigma is 3 divided by root n. So root n. So n was given as 30 in the question. Okay. So this will be 30. Same we have to do here. So this will be 27 minus 25 divided by 3 divided by root 30. Now solve this part.
The first one is minus 1.82.
So if you solve this part, it will become minus 1.82. Right? And this will become
3.65.
3.65. Now if you remember the properties of normal distribution, what it is, we can write it like this, that it is fz of 3.65 minus fz of minus 1.82. Right? Everyone knows how we write
Yes,
this?
yes, ma'am. Yeah.
Or should I explain it?
Upper limit minus lower limit.
Yeah. Okay, yeah. So this is the CDF. So this part we have to write first, and this goes at the last. So now you can see this is the answer. So which option is there? 3.65 positive and minus 1.82. So option number A is correct. Okay. So in the question, first of all, you should write the information, whatever is given to you. Okay. Whenever you are solving any kind of question, just write everything, whatever is given in the question, and then write, like mathematically, you have to write those things, and then mathematically write whatever is asked in the question, and then decide what you have to do, what you need to calculate, what formula you have to apply, and what method you have to follow. Okay.
Yeah, sure.
Now, anyone has any doubt?
Ma'am, before moving on, I just like explored another way, like what we could do it before, like putting the normalization part. We could just simply write the mean as x plus x1 plus x2 divided
Yes.
by n, and just multiply the n part to.
Yes,
like,
yes. Yeah,
both
I got
inequalities.
your point. Yeah, we can do in that method also. So in that method, you will, yeah. So here you will send the n to both the side, and then will it become the sum of those random variables, right?
Yes.
And then you can subtract the mean of that sum and the standard deviation of that sum. So you can use, yeah.
Could you
that
tell
method.
what is his method? Like, could you write that down
Okay.
once?
Yeah. So 1 minute. So suppose in the question it was that x bar is lying between 24 and 27. So you just write the value of x bar, like the formula of it. So this is x1 plus x2 up to xn divided by n, right? You can put the values of n later. I'm just writing it for the, like, in general, okay? Then you send the n to left and right side. It will become like this, right? And now you have seen that you have the sum of those random variables. You have to subtract the mean of these sum and divide by the standard deviation of this sum. So this is 24n. Should I write it as Sn, this sum, right?
Yes, ma'am.
Just for notation, for simplification, I have written it like this. Now we will do the calculation part here, put the value of n. Now this Sn, and you have to subtract the mean. So the mean of the sum comes out to be n mu. And the standard deviation becomes sigma root n. You have to do it on both the side actually. So here it will become 24n minus n mu divided by sigma root n, and here 27n minus n mu divided by sigma root n. And now you can put the values of this mu, n, and sigma. You can find it. Okay, this variable will become z. Okay, so in this way also you can find it.
Yes, ma'am. Okay, it's clear. We're just multiplying n on all both sides so that the mean will get converted into the sum.
Yes, yes.
Okay, okay, ma'am.
So if you look at it like mathematical terms, so in both the method you are doing the same thing. Okay.
Yes, ma'am.
Yeah, now solve this question. So what is the fourth moment of normal 0,9 distribution? Try it. So what you have to do, you should know the moment generating function, the general formula, and you should know that what is the moment generating function for normal 0, sigma as well. If you know these two things, you just have to do some calculation and all, and then you can find it.
Yes, ma'am. Ma'am, is it 243?
Okay, we'll solve it. Okay, one more thing I will write there. Yeah, so here you can see that in this, so we were getting this expectation of x square like this. So the general thing is that the coefficient like how we will decide which moment is this. So coefficient of lambda to the power k divided by k factorial. This is our kth moment. Now look back at this equation. So this is lambda to the power 1 by 1 factorial. its coefficient is first moment. Here power is 1, the value of k is 1. Now here you can see it is lambda square by 2 factorial. So k is 2 here. So this is giving you second moment. Similarly here we have lambda cube by 3 factorial. So its coefficient is giving you third moment. So that's how you can decide what is the value of k, which moment you are getting. Okay, so it depends on the lambda to the power divided by this factorial value. Okay, now go back to the question. Yeah. So we are given, suppose we have a variable x which is following normal 0,9. Okay. Now in general we know that mx lambda, this is equal to what? Expectation of e to the power lambda x. Okay, I'm writing the same thing again just to make you more clear. So again the same thing that we have done earlier also. We have to open the expansion of this e to the power lambda x. So this will be 1 plus lambda x plus lambda x square divided by 2 factorial plus lambda x cube divided by 3 factorial and so on. Okay, now we got that this will be 1 plus lambda expectation of x plus lambda square 2 factorial expectation of x square, and similarly we'll get the other terms, right? Now what we know is, we know that the MGF of x following normal 0 comma sigma square is e to the power lambda square sigma square by 2, right? This is something we know already. Now e to the power lambda square sigma square by 2. Again you can expand this term. Okay, we can use the expansion of e to the power x here also. So you can see this is the MGF of normal 0 comma sigma square. If I expand it, it will become 1 plus lambda square sigma square by 2. Then the second term will be, next term will be lambda square sigma square by 2, and this whole square divided by 2 factorial, right? Next will be lambda square sigma square by 2. Consider this this entire term as x. Okay, then you will understand. Then cube divided by 3 factorial and so on, right? Is this term clear to everyone?
Yes, yes.
Okay, I have just used the expansion of e to the power x. So you have to consider this term as x. Okay, and then apply the formula. Now you can compare these two. What do you have to compare? You can see. Okay, or if you remember, you just directly say that lambda to the power k divided by k factorial, the coefficient of this term is the kth moment. Okay, so what we have to find in the question, we are asked to find the fourth moment. So fourth moment is equal to the coefficient of lambda to the power 4 divided by 4 factorial, right? Now we have to see the coefficient of this term. Now in which term you will get the lambda to the power 4 divided by 4 factorial?
Third term.
Maybe next term, or replace lambda with lambda square sigma square by 2.
Fifth term.
In this term, right? Here we have lambda square only. In this term we have lambda square and then power 2. So this will give you lambda to the power 4, right? in this term you will get this is lambda square and whole cube. So this will give you power 6, right? So we have to use this term. Now let's write this term separately. So we have lambda square sigma square by 2 whole square divided by 2 factorial. Okay. Now from here we have to make it like lambda to the power 4 divided by 4 factorial, and then we have to check for the coefficient of this term. So if I simplify, it will be lambda to the power 4 sigma to the power 4 divided by 2 square, right? Which is 4, and this 2 factorial. What we have to make it? We have to make it lambda to the power 4 divided by 4 factorial. So what can I do here to make it 4 factorial?
Multiply.
Ma'am,
Multiply and divide by 3.
Yeah. So we
3,
have
ma'am.
yeah. So only 3 is missing, so we can multiply and divide by 3. Now I can write it lambda to the power 4 divided by the numerator thing will become 4. Sorry, denominator part will become 4 factorial, and the remaining is 3 sigma to the power 4, right?
Yes,
Now,
ma'am.
now you can see clearly that the coefficient of lambda to the power 4 divided by 4 factorial is equal to 3 sigma to the power 4. Now in the question we are given that x is following normal 0, 9. So this 9 is actually sigma square. Sigma square is 9, or sigma will be 3. So I can write like this, that this is 3. So it will be 9 square simply.
Yes, ma'am.
Now you can calculate it. So this will be 243. Okay, that's how you can solve these kind of questions.
Okay, ma'am, for this, coefficient, can't we write it in k terms? I mean, in a general term, like earlier. Yeah.
Yeah, in general terms, what?
Yeah, in general terms, can't we write it in k terms? So, or we need to derive like this only. So, for fourth moment, we suppose like if it is for second moment.
Yeah. So for
How
second
should we
moment,
do?
yeah, for second moment, if you are required second moment, we have to see the coefficient of lambda square divided by 2 factorial. Now you have to see from where you
Yeah.
can get this term. So again, you have to, this equation you will have to write always if you are given normal distribution, okay? Because this is the
Okay.
MGF of normal distribution. You have to expand it, and then you can find the like lambda square or lambda to the power k divided by k factorial. Now see at which term you are getting lambda square by 2 factorial.
Yeah, maybe second term only. Yeah, second term in this.
You have to look for the lambda to the power. This 2 factorial, 3 factorial, you have to do some manipulation, then you will get it. So lambda square you are getting in this term. So this is, so from this term you can see this is lambda square divided by 2. I can also write 2 factorial. This is same.
Yes.
And then its coefficient from the remaining terms are sigma square. So the coefficient is sigma square. So this sigma square will be the second moment.
Okay. If I ask third moment, just for to.
Yeah. So you
see the
can
product.
see, yeah. So you can see that you are not getting power 3, lambda to the power 3.
Yes.
So lambda, you can say that the coefficient of lambda to the power 3 divided by 3 factorial is 0.
Yeah.
Yeah, so the coefficient is 0, so the moment will also be 0.
Okay. So in question, if they ask for third moment, answer should be 0.
Yes.
Good.
Yeah. You can simply say that the coefficient will be 0. Okay, so the moment ultimately will become 0.
Ma'am, in that case, here we can find only even moments, right?
Yes, all the odd moments will become 0.
Okay, perfect. Yeah.
Now is it
Got
clear
it, ma'am.
to everyone? Any other question?
Yeah,
Any
it's
other doubt?
clear.
Okay, then we can go for the next question. Yeah, so here in a telecom system, each data file consists of 500 bits. So due to noise, each data bit received may have an error with probability 0.1. Now it is assumed that bit errors occur independently. So the first part is, suppose y represents the total number of bits without an error, okay? So in a certain data file. So which of the following is true? So what distribution y will follow?
Binomial, right, ma'am?
Binomial.
Okay, binomial with parameters?
E 0.9.
0.9, because without is asked.
Yeah. So you can simply see
Yeah.
in total we have 500 bits, okay? And y is representing the total number of bits. So y will be following binomial distribution, okay? So n will be 500 and the probability we have to see that it should be without an error. And here the probability is given for error. So 1 minus 0.1 will be the probability for without error, right? Simply we can find. So y will be binomial 500 comma 0.9. Okay, is it clear?
Yes, ma'am.
Ma'am, if there was only one bit, then it was Bernoulli, no?
Yes, yes.
Ma'am, actually, binomial is extension of Bernoulli only, right?
Yes, yes.
Okay, yeah, yeah.
Yeah, so option number C is correct. Okay. Now the next part. So using central limit theorem, find the approximate probability that there are more than 53 errors in a certain data file. So you have to again use CLT here. Okay, its value is missing. Okay, I'll write this value. Yeah, try to solve this question.
Ma'am, can we start from 1 minus probability of x is less than or equal to 53?
You have to decide the variables. Accordingly, you have to find the mean, standard deviation and all. You have to apply it. You try it out and then I will solve.
Yes, because they're showing there are more than 53. That's why 1 minus and probability of x is less than or equal to 53.
Yeah, that also you can do, or you can simply take x greater than 53.
Yes.
Yeah, both the ways are correct. Okay, this value is 0.67. Okay, now I'm solving it. So we are asked to approximate the probability that there are more than 53 errors in a certain data file. Okay, read this statement carefully and we have to solve according to that. So now let's take some random variable. Suppose A. Suppose AI is some random variable. You can take like any notation you can use. Okay, so this is suppose 1 or 0. This is a Bernoulli random variable. So in the question, you can see in the main question, it was given that each data file consists of 500 bits. Okay, and each data bit received may have an error with probability 0.1. So ultimately, you can see that the data bit received may have an error or it may not have an error, right? Two possibilities are there.
Yes, ma'am.
Okay, so we are taking this variable, that AI. So it is taking value 1 when there is an error in data bit. So when there is an error, then it is taking value 1, and when there is no error, it will be 0. Okay, this will be no error. Now you can see that we are asked to calculate the probability that there are more than 53 errors, which means we have to look for the total number of errors. So we can say that we have a variable x, which is representing the x is representing the total number of errors. Now, how can you find the total number of errors? So x is ultimately equal to the summation of these AI, right? This A1, A2, up to A 500. No, 500. See, first of all, we are deciding the
500 bits.
Okay, so for total 500 bits, okay, so for each bit we can have an error or we cannot have an error. Two possibilities are there. Okay, so this AI is representing. Okay, so A1 is for like bit number 1. If there is an error, it will take value 1, or otherwise it will be 0. So like this, we can have total possibilities are 500. 500 bits in total we have. So x, okay, is equal to A1 plus A2 up to A500. So it is actually representing the total number of errors, okay, out of those 500 bits that we have. Now, we have to write this statement mathematically. So we have to find probability that x, okay, the total number of errors, it is greater than 53. Okay. Now all these things is clear?
Yes, ma'am.
Okay, how I have written this statement?
Yes, ma'am.
Yeah. So first of all, whenever you are given this type of question, you just be mindful of that, whatever is given, what is asked. Try to convert it in mathematical terms and then solve that question. Okay. So ultimately, we have to find probability x is greater than 53. Now you know that you should know the mean of x and the standard deviation of this quantity x, right?
Yes, ma'am.
To make it like that, if you want to use CLT, so we have to find the expectation of x and the standard deviation of x. So this is question mark. Now expectation of x, so this is equal to the expectation of A1 plus A2 up to A500. Okay, and the variance of x, this is also variance of A1 plus A2 up to A500. Okay, now this will be 500 times expectation of A1 or AI, right? And what will be the expectation for AI? So you can
0.1.
that, yeah, AI is actually following Bernoulli distribution with probability 0.1, right? probability for error
Yes,
was
yes.
0.1. So AI is actually following Bernoulli's 0.1.
Yes.
So the value of P here is, or the value of mean will also be 0.1 for AI, right? So 500 into 500 into 0.1, which is 50. Okay, this will be the mean for X. Similarly, we can find the variance. So this will be 500 into, now what is the variance of AI?
NPQ.
N
So
into
500 into
P.
0.1 into
I am
0.9.
0.01.
Yes.
0.01. Sorry, 0.09.
So this will be 0.1
Into
into
0.9.
Okay. For Bernoulli, the variance
45.
is PQ. If you have binomial, the variance is NPQ. Okay. So what will be this value?
45.
45. Now you can use
Uh,
these things here. Okay.
Ma'am, if you could explain me why you put 0.1 into 0.9.
Yeah. So you can
So,
see.
yeah,
So if you look at this term carefully, this is variance of A1 plus variance of A2 up to variance of A500. Okay? So you have to
yeah.
add the variance of these terms. And these all AI are following Bernoulli 0.1. Okay.
Okay.
And if you have, okay, I'm writing it here that if you have a variable X, you will get confused.
Madam, I got it. I got it, ma'am. Sorry. N into 1 minus P is what you. Sorry. P
Yeah,
into 1
so
minus P is what you.
P into 1 minus P is the variance for Bernoulli. Okay.
Got it, ma'am. Got it.
Yeah.
Sorry. Continue, ma'am.
Yeah, it's okay. Okay. Now simply subtract the mean. So X minus 50 divided by standard deviation is square root of 45. Same thing we have to do at right hand side. So 53 minus 50 divided by square root of 45. So this term will become standard normal variable, so Z. This will become 3 divided by square root of 45. We can write 5 into 9. Right?
Yes, ma'am.
So Z greater than 3 divided by root 5 into 3. So ultimately it has become 1 by root 5. Okay. Now you can write it in the CDF format. Okay.
Yes.
So this will be 1 minus fz of 1 by root 5, right?
Yeah. So this is already given in the question. So 1 minus 0.67.
Yeah, 1 minus 0.67. Okay, so this value is given. So
0.33.
yeah, 0.33 is the answer.
Ma'am, please scroll little down. Little more. Yes.
Okay, is this clear to everyone?
Yes, ma'am.
Okay. Okay, next is this. So here, X is a random variable having the gamma distribution with parameters alpha equals to n and beta is equals to 1. And if X is following gamma, alpha, comma, beta, okay, then what is the expectation and variance? This is given to us. We have to use CLT. These values are given, okay, and we have to find the value of n such that this probability value is given. From here, we have to find the value of n. Try this question. Okay, so in this question, we are given this inequality, okay? So we know that if you subtract the mean and divide by standard deviation, you can convert it into that. It will tend to follow standard normal distribution according to CLT. Okay, so some like this inequality is given. In this inequality only we have to do some manipulation, right? And we can convert it into that
Yes,
form,
ma'am.
and from there some calculation, and then we can find the value of n. Okay, so we need to know the mean and standard deviation of this variable x, right? Now x is following gamma, alpha, comma beta, and the value of alpha is n and beta is 1. Now we are given the values of mean and variance also. Just put the value of alpha and beta and you will get the mean and standard deviation for x here. Okay, so x is actually following gamma with parameter alpha is equal to n and beta is equal to 1, right, according to the question. Now expectation of x is alpha divided by beta. So alpha is n, beta is 1, so expectation of x will be n, right? Now variance of x, so variance of x is alpha divided by beta square. Okay, so this is given in the question, you can see. So variance will be n divided by 1 again, so it will again be 1 n only, right? And now we are given that probability of mod of x x divided by n minus 1 greater than 0.01 is less than 0.01. Okay. Okay, we have to apply CLT. So what we usually do is we have to subtract the mean and divide by the standard deviation. So, okay, first I am writing this only. So we can write it like this: x minus n divided by n. Okay, same thing. I have done nothing, just simplified version of it. If you
Yes,
take
ma'am.
LCM of both, okay, same thing I have written. Now x minus expectation of x divided by standard deviation of x. Okay, so it should be x minus n divided by square root of n, right? Because the both mean and variance are n only. Okay, so we want this term actually, right, to make it a standard normal. What we are given here is x minus root n divided by n. So what we can write it as probability, we can write like this: x minus n divided by square root of n, and 1 is square root, we can transfer it at this right hand side. Yeah, here it should be root n also. Is it clear? You can simply understand it. And we can write n root n, and 1 n is transferred to this side.
Yes, ma'am. It's clear.
Yes.
Okay. Now you can see that this is something which will be following the standard normal, right? So we can write that mod of z is greater than 0.01 times root n less than 0.01, right?
Yes, ma'am.
Now I can write, so this is mod z. So first of all, we have to remove the mod sign. So you know that if you take the reason, what it is representing is, so suppose this is 0.01 root n. The mod z greater than, which means it takes these two areas. Do you all know this thing?
Yes, ma'am.
Okay, so these two shaded region is covered in that inequality. So I can write this term as 2 times of this, because these two blue shaded region are same. Okay, because it is a standard normal distribution which follows symmetry. Okay, it is symmetrical. So these two regions will be same. So I can write 2 times of one region. So 2 times of z greater than this region. So z greater than 0.01 times root n. Is it clear?
Yeah.
Yes, ma'am.
Okay. Now again I can write it like this. 1 minus probability z less than. So this will become the CDF of it. So fz 0.01 times root n, which is less than 0.01. Okay, if you write probability, so this is probability z greater than n, that you can simply write. If suppose this is some value x, suppose some constant c, so you can write 1 minus probability z is less than or equal to c.
Z less than C.
Okay, just a general result
Yes.
we have used. Okay, yeah. Now solve it. So you can transfer this 2 to this side. So it will be 1 minus fz 0.01 root n less than 0.01 divided by 2. So 1 minus fz 0.01 root n. So this is less than 0.005.
Yes.
Okay. Now the value of fz 0.01 root n, if you do the transfer, and also this will become 1 minus 0.005. So 0.995, right?
Yes.
Okay. Now some values will be given to you in the question that you have to check. Okay, so you can see 0.995. This is given, or this value is also given. You can use any of these values. So you can see 0.995 is when fz at 2.58. So this value at point 2.58, it should be there. So given fz 2.58, okay, this is equal to 0.995. Now put it in that inequality. So we can write that fz 0.01 root n, that will be greater than fz 2.58, right? At the place of 0.995, I have replaced it with fz 2.58. Okay. Now it will be 0.01 root n, that should be greater than 2.58 simply. Now from here you can find the value of n. Okay, which implies that value of n will be 258 square. Sorry, it will be greater than this. Okay, n is greater than 258 square. So n is greater than, square this term. So this will be 66564. So the n, which is the sample size, so that should be greater than this value. So greater than 66564. So after that, this point is coming. Okay, so this is the value of n. Is it clear to everyone?
Yes, ma'am.
Okay, this is the value of n. Okay, I hope it's clear to everyone.
Ma'am, option C is also following this inequality, right?
Yes, so I think the question it should be like, what is the minimum value of n? Okay, so if it is asked the minimum value, then it will be this value.
Yeah.
These all questions we have. Anyone has any doubt?
Ma'am, can you get the PDF?
Yes, it will be uploaded on the portal.
Okay. Okay, thank you, ma'am.
Yeah, thank you everyone. We can leave now.
Hello, ma'am.
Yes.
I wanted to ask you a question regarding week 7 short notes. There was some confusion I have been.
What short note?
And yeah, you uploaded short notes PDF Google Drive in previous
Okay,
meeting.
live session notes.
Yeah.
Okay.
It was Sneha.
So
Sneha ma'am who shared those notes in the last session, right, Amrita?
Yes.
yeah, I was asking them when n बराबर 5 या 20 या 100 तो there is sample 1 sample 2 sample 3 this I understand लेकिन then it's a sample generated by simulation it means artificial ना
Yes.
sample generated by simulation then it means artificial ना
Mm-hmm.
then will it be given in exam or we we have to
No.
generate
So these simulation you can perform on like on Python and all.
okay thank you
Yeah, not in the exam. You will not be given this type of question.
okay, thank you ma'am.
Ma'am, in quiz 2, what should be the weightage? Like most of the questions comes from 6 to 8 weeks only, right? But
Five.
whole syllabus is 5 also. So okay, from 5 to 8,
See, the
more
syllabus is
weightage.
from entire week 1 to 8, but the more
Week
weightage.
1 to 8.
Yeah, but
Yeah.
you need to focus more on week 5 to 8. So that will cover
Okay.
most of the portion.
Okay, sure. Thanks.
Thank you ma'am.
Yeah, thanks everyone.